Okay, very well. Welcome back. So now we calculated the market price for bond A and for bond B. So next, let us go to calculate yield to maturity. Let's go back to let's go back to the question and see. Let's go back to the question and see how we can calculate yield to maturity. What did they say about it? Okay, now I'm sharing the question here, which is talking about uh, requirements B. So requirement B says, irrespective of your answer in A, assume bond A is issued at 1,054. And you see, that's what we got. Bond B is issued at 1,026. That's what we got. That means our answers for A was correct. Calculate the yield to maturity of each bond at the time of issue. Of each bond at the time of issue. Now, let us move ahead. Okay, now, yield to maturity. I have already given how steps or things needed in order to get yield to maturity. So how do we calculate yield to maturity? For bond A, I said we need coupon, okay? Calculation of yield to maturity, YTM. So for bond A, we need what? Coupon. And we calculated our coupon, 10%, right? 10%, which is equal to 10 divided by 100 times 1,000 naira, which is equal to 100 naira. That's our coupon. Redemption value. I said we need redemption value. Now, at 8%, 1.08 times 1,000 naira equal to 1,080. And I said we need market value of the debt or issue price, market value of the debt. They said we should use 1,054, regardless of what we got in A above. After all, we also got 1,054. Then number 4, we need maturity period. Maturity period for bond A is 2 years. Bond A maturity period is 2 years. Then lastly, we need to assume discount rate. Assume discount rates. So keep it simple. I will assume 3% and 5%. Keep it simple and just keep it simple and small digits. 1 digit is fine. So we've itemized all the things needed to calculate yield to maturity for bond A. So let's quickly go ahead to calculate the yield to maturity. Good. Say year. Okay. I will say year 0. I will say year 1 to 2. Then I will say year 2. Please follow. Now, then cash flow, CF. Cash flow in Naira. What is the market value of bond A? It is 1,054. That is going to be, this is 1,054. So that is going to be a cash outflow because that is the investment in year 0. Okay. What is the coupon we are going to be receiving for 2 years? 100 naira. We are going to have 100 naira in year one, 100 naira in year two. Now, what is the redemption value? The redemption value is 1,080. Okay. Now, what is the DCF? We have two DCF, lower rate and higher rate. The lower rate is 3%. So let us use 3% first of all. Here, the DCF of year zero is always 1. Okay. Now, just do 1.1 plus r raised to power minus n. So which is also means 1 divided by 1 plus r. That is 1 plus r in this case is going to be 1.03. R is 3%. 3 divided by 100, it is equal to 0.03. 0.03 plus 1, it is equal to 1.03. So just say 1 divided by 1.03. What do we have? I have 0.971. That's the discount factor. Sorry. Sorry. Not this. No. Okay, good. Let me quickly explain something. Because we have constant cash flow for year one and year two, okay, we are going to use annuity factor, not just constant cash flow for year one and year two. The constant cash flow in this case is 100. And because we have constant discount rate, which is 3, so we are going to use annuity factor. Let me quickly say it here. So annuity factor is equal to annuity factor. Annuity factor. What is it? 1 minus 1 plus r raised to power minus n divided by r. Now, that is annuity factor. Okay. I would say use when cash flows and discount rates are constants throughout the years. So use it when discount rates and cash flows are constant. We have a constant discount rate, which is 3%. We have a constant cash flow, which is 100. Okay. The second one is present value factor. Okay, that is 1 plus r. That is 1 plus r raised to power minus n. So I say use when cash flows and or discount rates are not constant throughout the years. If they are not constant, all right, if they are not constant, you use present value factor. Okay. When we were calculating market value, you will notice that, yes, we can argue that we have constant cash flow to a reasonable extent, but we do not have constant yield or constant discount rate. Year one, we use 9.7, year two, 10.7, and so on, year three, 11%. So, but in this case, we are calculating yield to maturity. We have constant cash flow and we have discount rate. We assume the rate 3%. So it is going to be constant. Okay, so let us come back here. Now, if it is going to be constant, so we are going to do annuity factor. So annuity factor is, now, I want you to pick it from the table. If you go to the table inside the question, and the question we are looking at, go to the table page. Just scroll down to the table page. After formula page, you will see the table page and you will see annuity table and you will see the formula I wrote on top of the table. Okay, look for 3%. 3% for 2 years. 3%, trace it to 2 years. I am seeing 1.913. That is 1.913. Okay, so because we have constant cash flow year 1 to 2, so annuity factor is the combination of present value factor. Okay, so in year 2, we are going to do present value. That is 1.03 raised to power minus n raised to power minus 2. That is 1 plus r raised to power minus 2. So I got 0.943943. So our PV in Naira is going to be 1054 negative, and 100 times 1.913. I have 19.13, and 1080 times 0.943, 0.943. That is 1018. Okay, 1018. So add everything together. 1018 plus 19.13 minus 1054. Our NPV. Okay. So I got NPV, excuse me, 3%. I got NPV, a negative figure. Let me check my figures again. 1.03 raised to power minus 2. 0.943 times 1080. I got 1018. Then 1.913 times 100. So I got, okay, yes, 1.913 times 100. I got 191.3. 191.3. It is not 19.3. Sorry, 191.3. Okay, so 191.3 plus 1018 minus 1054. I got 155.3 as the NPV. Okay, positive. Now come to the higher rate, the DCF 5 with 5%. 5%. DCF 5%. Okay, year 0 is always 1. Year 0 is always 1. So go back to the table, look for 5% for 2 years. Trace it. I got 1.859. 1.859. That is the annuity factor of 5% for 2 years. 1.859. Then I will now do for year 2, 1.05 raised to power minus 2. I got 0.907. So our PV would be minus 1054. Then you now say 1.859 times 100. I got 185.9. Okay. Then we have 0.907 times 1080. I got 979.56. Okay, 979.56 plus 185.9 minus 1054. I got another positive NPV of 111.46. Okay, that is another NPV. Okay, so we've gotten our two NPVs. Now we are going to use this IRR formula, which is yield to maturity. It is IRR formula we are using, which is still our yield to maturity formula. It is equal to lower rates plus NPV. I always say NPV of lower rates divided by NPV of lower minus NPV of higher rates. That is higher rates minus lower rates. So I don't like to say negative NPV or positive NPV because any one you get, you can see the second rate, I got positive NPV. Just move on with it. Your answer will be fine. The signs will regularize and your answer will be fine. It is not until you get negative NPV. All right. That is why I don't say negative NPV minus divided by negative NPV plus. No. Instead of saying negative NPV or positive NPV, I say NPV of lower rate, NPVL, divided by NPVL minus NPVH. Okay, so let us put everything in the format. So NPV of the lower rate is 155.3, NPV of the higher rate is 111.46. Okay, we say, therefore, yield to maturity equals to lower rate 3 plus, the plus is there. Okay. 155.3, 111.46. Okay. NPV of lower 155.3, 155.3 minus 111.46. Okay, multiply by higher rates 5 minus lower rates 3. So punch your calculator. Our YTM will be equal to, punch it in the calculator, 155.3 divided by, open a bracket, 155.3 minus 111.46, close the bracket, equals to this. Multiply by 5 minus 3 is 2. Multiply by 2 equals to this, plus 3. I get 10.1%. 10.1%. Approximately, I got 10.08. Approximately 10.1%. Okay, so that is yield to maturity. That is yield to maturity for bond A. Very quickly, let us go and calculate yield to maturity for bond B. Yield to maturity for bond B. Yield to maturity for bond B. Okay, now for bond B, We are calculating yield to maturity for bond B. What are the features? Let's state them again. The coupon of bond B is what? 12%. 12%. That is 12 divided by 100 times 1,000 naira. That is equal to 120. That is equal to 120 naira. Okay, what is the redemption value? The redemption value, the redemption value is equal to 1,000 naira, because they say it is going to be redeemed at par. It is going to be redeemed at par. Then I say, what is the market value? Examiner has already given us the market value, all right, regardless of what we got. And we got the same thing as what they gave us, 1,026. That's the market value of bond B. Then what is the maturity? The maturity of bond B is maturity period. Maturity period. It is equal to 3 years. Okay. And the last one, assumed discount rates. Okay. Let us do the same thing. 3% and 5%. 3% and assume discount rate, 3%, 3%, and 5%. So let us go ahead to use IRR to calculate our bond B, yield to maturity. Now it goes this way. Okay, bond B yield to maturity. We have year, okay, and I'll say year 0, year 1 to 3, and year 3. Our cash flows would be in Naira. Our cash flows will be in, our cash flows will be in Naira. Year 0 is negative of 1026. 1026. Okay. Then year 1 to 3, coupon 120. Year 3, 1,000. Okay. What is going to be our DCF? Is 3%, the lower rate. Year 0 is always 1. Go to the table again, to the annuity table again. Check for 3% for 3 years. I am seeing 2.829. 2.829. Then punch your calculator. 1 plus r raised to power minus n. 1, that is 1.03 raised to power minus 3. That is 0.915. So what is going to be the PV? The PV in Naira, negative of 1026. Okay, that is 1 times, okay, 120 times 2.829. 2.829 equals to 339.48. 1,000 times 0.915. I got 915. NPV equals to 915 plus 339.48 minus 1026. I got 228.48. 228.48. Okay. Now let's move on. the second DCF, which is the higher rate, 5%. Year zero is always 1. Go back to the table, check for 5%. Annuity factor of 5% for 3 years. I am seeing 2.723. 2.723. 2.723. Then punch your calculator. 1.05 raised to power minus 3. That is for year 3. I'm getting 0.864 approximately. Then the PV will be equal to, year 0 is minus 1026, okay, 2.723 times 120. I am getting 326.76. Then 0.864 times 1000. I'm getting 864. Okay, 864 plus 326.76 minus 1026, which is 164.76. That is the NPV of the lower rate. So let us calculate our IRR. Okay, 228.48. Okay, lower rate 228.48 divided by 228.48 minus NPV of the higher rate 164.76. 164.76. Okay, this lower rate 3 plus all of these, all of multiplied by 5 minus 3. That is our yield to maturity. Okay, so I'm using IRR formula. I've written it before. That's why I'm not writing it again. I'll say 22. So I'll say 228.48, 228.48 divided by, open a bracket, 228.48 minus 164.76, close the bracket, equals to this, times 5 minus 3, that's 2, equals to this, plus 3, that is 10.17, approximately 10.2%. 10.2% yield to maturity. Please, when you are punching this calculator, endeavor to follow the rule of BODMAS, okay, so that you will get the correct figure, okay, so that you get the correct figure. So, please, I want to advise in this same vein, please go to check this question, okay? Go to check this question, okay? And I think you have it. ICAN, May 2016, question 3, that's Skylet. Okay, please, it's the same thing, so that for your practice, you can consider it as an assignment. Please use it to practice. Please, I beg you. Okay, so let us continue before the time goes off. Okay, let me use this opportunity, the remaining time that is left, to explain the other parts of this bond or debt thing. There is something we call bond duration. I repeat, bond duration. I repeat, bond duration. Okay, so now bond duration, and you will see it. I sent some material to you sometimes ago. All right, and I think the material is titled P4 class note. Okay, see it as excuse me, P4 class notes. I'm trying to open it from my system now. I have sent it to you before, P4 class notes. So I want to use it to explain the bond, the bond duration, bond duration. Okay, duration. Okay, now, okay, okay. Now, now I have uh okay, bond. Let me put it full. Bond duration or Frederick Macaulay duration. Good. All right. Now you will see it. Let me share the notes. Let me share my screen. You will see the notes. You have it already. We called it P4 class notes. P4 class notes. I've sent it to you on WhatsApp before. So if you go to page 48, you will see Frederick Macaulay duration method. That is bond duration. If you go back, there are other types of duration you can see. Technically, duration measures time taking to recover cash flows from investment or to recover the PV. But in the case of bond, it's also measured time taken to recover the cash flow. All right. So Frederick Macaulay is of the opinion that the maturity of the bond is necessarily not the duration, is necessarily not the duration of the bond, that the duration of the bond is always lower than the maturity, since most of the cash flow attached to the bond would have been uh, recovered before the end of maturity. Now, so that is it. Please try to read it up, please. Now, I want you to pay attention to the steps. You can see steps required to calculate bond duration. Step one, establish cash flows arising at each future time period. That is the cash flow attached to the debt. Okay, the future cash flow attached to the debt. Step two, calculate the present value. Calculate the present value of this future cash flow discounted at IRR, that is gross yield to maturity. So when we are calculating, we are using yield to maturity. You know, we got yield to maturity for bond A, which is 10.1. We got yield to maturity for bond B, which is 10.2. Okay, yield to maturity of the security. Incidentally, the sum of this figure must be the current price of the bond. It must be equal to the current price of the bond. Well, if you calculate it, if it's not equal, it will be rounding off error. So they are saying that if we calculate the PV of these cash flows using yield to maturity as the discount rate, by the time we calculate the PV and add all the PVs together, for bond A, it should be 1054. For bond B, it should be 1026. But, well, it may not be so because we have done a lot of approximation when we're calculating yield to maturity. But it should be very close, all right? It shouldn't be too, like maybe the difference among them will be 10 or 20. It should be close. Okay, step three says, calculate each year's discounted cash flow as a proportion of the value of the bond. So what you are going to do here is that, okay, for bond A, for example, what is the market value of bond A? 1054. What is the PV you got in year one? Whatever PV you get in year one, do proportion of it. Do the PV divided by the market value. That is the proportion. That is the portion. Do for year two, PV of year two by market value. That's the portion. For year three, PV of year three divided by the market value. That's the portion. PV of year four divided by the market value. That's the portion. And so on till you get to the final year. Okay, then step four, that is a proportion. Step four, now talk about take the time from investment. Take the time from investment to each discounted cash flow and multiply by respective proportion. Now you have gotten proportion in year one. That proportion, multiply it by year one, but multiply it by one. You've gotten proportion in year two, multiply the proportion by two. You've gotten the proportion in year three, multiply the proportion by three. Year four, multiply the proportion by four, and so on. So when you do that, you say finally sum the weighted years together. So after you multiply, all the things you have got the weighted years, just add them together. That is the duration. Okay, so that is the duration. Okay, so very quickly, if we are going to calculate, if we go back to the question, okay, if we go back to the question, you will see that if you go back to the question, you will see that, okay, now the question says we should calculate the duration for the two bonds. That is the question 2. It says calculate the duration for the two bonds. That's question C, 2C. Calculate the duration of each bond. What does duration measures? I have mentioned it now. Duration measures time taken. All right, time taken to recover cash flows. Now, if we are going to calculate the duration okay, so I am going to stop the video right now. So in the next video, you are going to see the way we would calculate bond duration. Thank you very much. See you in the next video. Cheers.